Hello and welcome to my channel. I am Mensa Augustine. Please, if you're new here, kindly subscribe to my channel. And if you have been watching my videos and you have not yet subscribed, please kindly subscribe us to the mathematics community. In this lesson, we are going to find the general solution of into bracket cosine of x minus x times sine of x plus y squared dx plus 2xy dy equal to 0. Join me as we go through this step by step. Now, if you look at this question is in the form m of xy dx plus n of xy dy equal to 0, which is a differential equation. Now, for this differential equation, let us verify whether it is exact or non-exact. Now, we take m of x y equal to cosine of x minus x sine x plus y squared, and n of xy equal to 2xy dy, equal to 2xy. Now, we check whether the partial derivative of m of xy with respect to y is equal to the partial derivative of n of xy with respect to x. Now, if we differentiate cosine of x minus x sine of x plus y squared partially with respect to y, here, since there is no y attached to this cosine of x is a constant. So if we differentiate cosine of x partially with respect to y, we get 0. Similarly, if we differentiate x times sine of x with respect to y partially with respect to y, we get 0, since there is no y attached to this. If we differentiate y squared partially with respect to y, we are going to get 2y. Now, we take the partial derivative of 2xy with respect to x. Now, this one will give us, if we differentiate 2x, you get 2, and y is a constant. That is very, very simple as that. Now, since the partial derivative of m of x y with respect to y is equal to the partial derivative of n of xy with respect to x are equal, then we say that the differential equation is exact and the general solution is f of x y equal to a constant. That's very simple. Now, in order to continue, look at m of xy and n of xy. Which of them is very easier for us to integrate? You see that this one is easier to integrate than this one. So we just take this one. Very, very simple as that. We just take this one and then integrate using this path. So we are going to take our f of xy equal to the integral of 2xy dy. Yes, we have dy. So let's do this integration. So we have f of xy is equal to, we are integrating it with respect to y. So 2x is a constant. So if we integrate y, you get y squared divided by 2. So you're going to have 2x y squared divided by 2 plus a constant. Now, what should be the constant? The constant should be a function of x, because here x is a constant. So we write, let's say, g of x. Very, very simple as that. Here we are not going to write, let's say, c, k, or anything. The constant may be a function of x, because here we have x attached to y, which is a constant. So we are having our f of xy equal to xy squared plus g of x. That is our constant. Now, very, very simple as that. So here, we are going to differentiate this function partially with respect to g of x and then continue. So if we find partial derivative of f of xy with respect to x, we are going to get partial derivative of xy squared rather plus g of x, and this will give me y squared plus g prime of x. This g prime of x means that I've differentiated this function g of x. Very, very simple as that. Now, we will see that we have this m of xy here. That's very simple. We have this m of xy here, which is equal to m of xy is equal to the f on the x, and n of xy is also equal to the f on the y. So it means that what we've gotten here is equal to this. Very simple as that. So we are now going to write cosine of x minus x times sine of x plus y squared equal to y squared plus g prime of x. And here it's very easy for us to do. This one will cancel this. So we have g prime of x equal to cosine of x minus x times sine of x. So what do? We are going to integrate this to find our g of x. Wow, that's very simple. Hope you are enjoying the lesson. Kindly subscribe, share, and leave your comments. Now, if you integrate this, you are going to have g of x, because if you integrate this, you get g of x. And then you integrate this, so that will give us the integral cosine of x dx minus the integral x sine x dx. Now if we integrate cosine of x, we get sine of x minus the integral x sine of x dx. Now for this integral, we will use the integral by parts. So check the description for more videos on integral by parts. Now we have integral u dv is equal to uv minus the integral v du. So for this integral, x is easy for us to integrate, right? We let our u equal to x So okay, let's use the eyelids to get there. So if you have an integral of this form, you check if you have inverse trig function, right? If you don't have any inverse trig function, you don't have any logarithmic function, but you have an algebraic function, that is x, and you have a trigonometric function, that is sine x. So this one is easy for us to differentiate, right? Okay, so we are going to use this one as our u, and then you take this one as our dividend. So here we take u equal to x, and then we take dividend equal to sine x dx. Great. So we have du equal to dx, and if we integrate this, we have v equal to minus cosine of x. If you integrate sine x, you get negative cosine of x. Please don't bring the integral constant. Let's continue. So you have our integral u dividend, that is x, and dividend is sine x dx equal to uv, that is x times minus cosine x, that is negative cosine x minus the integral v, and this is our v, minus cosine of x, and here du equal to dx. Very simple. So you see that this negative will cancel this negative, so we are going to get positive. Okay, let's continue. Now we have negative x cosine x plus integral of cosine x. So that will give us minus x cosine of x plus, if we integrate cosine of x, we will get sine of x plus the integral constant k. So we are going to put this one here. So now we have our g of x to be equal to, that's very simple as that, sine x minus x cosine of x plus sine x plus k, and that will give us, wow, that's very simple. That will give us sine x plus x cosine of x minus sine x minus k, and that is equal to x times cosine of x minus k equal to our g of x. So our original function, the first one, I've cleaned it, but we'll get it here. We took this one as our f of x equal to the integral of 2xy dy, and we had xy squared plus g of x. So now we are going to have our f of x y equal to xy squared plus x cosine of x minus k. Or we can write it as x squared y x squared. It's not x squared, rather xy squared plus x cosine of x equal to c. That is very great. Very simple as that, because we said that once we prove that the equation is exact, then f of x y is equal to c. That's a constant. Very simple as that. So you have xy squared plus x cosine of x equal to c. That is it. This is our f of xy. So if we equate it to c and send this integral constant here, a constant plus a constant is still a constant. So you see this constant there. So this is the general solution of our differential equation, and the differential equation is exact. Thank you for watching. Kindly subscribe to my channel, leave your comments and share my videos. Bye bye.